All right, guys, I got a question for you. If I shoot 10 of these paper balls into that trash can over there in the corner, what's the probability that I would make 7 or more of them? Now, this is a binomial distribution question, but in order to answer it, the first thing we need to do is find out what's the probability that I would make any individual shot out of those 10. And the only way we can figure that is if I collect some data. So let's go ahead and start collecting that data. Hello and welcome back. My name is MrCaproni and this is Probability and Statistics. Today we're going to be looking at binomial distributions, which is the first of the 3 probability distributions that I'll be covering in my videos. We got binomial, geometric, and Poisson. So stick with me if you want to get all 3. But today we're going to be looking at the in and outs of a binomial distribution. What makes it binomial? What are the pieces of the binomial distribution? And what's the formula for how to find the probabilities with binomial distribution? And then if you stick around to the end, we'll go back and answer that question of what is the probability that I would make 7 out of 10 or more of those shots from the beginning of the video. So there are tons of different probability experiments that you could be doing. What makes one a binomial distribution? Well, a binomial distribution has 4 things in common every time. First off, it has to have a fixed number of trials, and each one of those trials has to be independent of each other. So what would that mean in context of this situation we were talking about earlier? Well, I was taking 10 shots. I told you guys I want to know the probability that I would make 7 or more of the 10 shots. So my fixed number of trials were 10. That's how many times I was going to be attempting this probability experiment. The second thing is that there can only be 2 possible outcomes, a success or a fail. Now, you can get extremely creative as to what you consider a success or fail. For example, if I'm trying to see what % of students fail my class, I might actually consider that a success because that's what I'm counting, is how many failures there were. So it can get a little confusing with wording, but basically there can only be 2 outcomes to your experiment, and you get to choose and label how you think it is a success or a fail. Now, the third one is that the probability of success is the same for every trial you do. Now, this is a little shady on the one we're talking about because maybe or maybe not, I might get better as I shoot. But for the most part, we would say that the probability that I'm going to make a ball into the basket every time is probably going to be about the same. I'm probably not learning too much as I go. So we're going to say that they are indeed going to have the same probability every time I shoot that ball. But this could be the same for flipping a coin or anything else. No matter what, every time I flip that coin, it's going to have the same probability of flipping heads or tails. The last one is that the random variable is based off the number of successes. This is different than a lot of probability situations because a lot of times you're talking about the actual probability of success. In this case, we're finding out the probability that there is a specific number of successes out of our total number of trials. So in this case, we are talking about 7 or more successes instead of just talking about the probability of me making a basket or not. So next off, we got to take a look at the notation that goes along with a binomial distribution. Now, we need to know this notation so that we know the proper things to fill in when it comes to looking at our formula or using technology to find the answer. So the first one we need to know is that N usually stands for the number of trials. All right. The second one we look at is P, which is the probability of success of a single trial. So in this case, we're not talking about the number of baskets I make. We're talking about the actual probability that I would make a single basket or into the trash can each time I'm doing it. So what is the probability of me actually making it into the trash can? The next one is the probability of failure, which you can easily find by just doing 1 minus P, the probability of success. So it's kind of a complement. It goes, success or fail, one or the other, they need to add up to 100%. But Q represents the failure. X is the number of successful trials in question. In this case, we actually have a range of numbers because I said 7 or more. So that means that X has to be 7, 8, 9, or 10 in this situation because that's how many successes we are considering with the question that was asked. Lastly, let's talk about the actual formula for a binomial distribution. You can see it right here, and it does seem like it's got a lot going on, but if you notice, the n, p, q, and x are actually all the numbers from our last slide in terms of important notation for the binomial distribution. The one that was not there is that c, and that c is actually part of a larger formula for combinations. If you don't know anything about combinations, go ahead and check out the other video above, where I go ahead and cover a whole bunch to do with combinations and permutations together. Now, if you don't know anything about those, here's the formula for combinations, which does make it look a little bit more complex. And for this reason, a lot of times we're going to use technology to solve a binomial distribution probability question. Now, looking through here, I have a list of ways that you could use tech for that, a lot of them being free. Now, the first one, TI calculators, would be any type of calculator from Texas Instruments pretty much has a binomial distribution inside of it. And you can actually just plug in the variables that we've mentioned in the notation section, and your calculator will just pop out the answer for the probability. You can also do things like this on geogebra.com, which is a free website for calculations, or desmos.com, or really you can just search the web for any binomial distribution calculator, and usually it's just going to ask you for n, p, and x. Sometimes q, sometimes not, because a lot of times a calculator can figure out that 1 minus p will give it q, so you don't always have to fill that in. But a lot of times we will use technology to find this answer instead of actually plugging it in by hand. And now, the moment you've all been waiting for. What is the actual answer to the question at the start of this video? What's the probability that Mr. Caproni is going to make 7 or more out of 10 shots into the garbage can from across the room using very lightweight paper that is really hard to throw? So first off, 10 is going to be our number of trials because we stated that from the very beginning that this is going to be out of 10 attempts. Now, in terms of the probability of success or the probability of failure, that is actually what I was doing at the beginning of the video. Was I took 50 shots to go and see how many of those 50 I made to give myself a base probability of success versus fail. Now, out of those 50 shots, I ended up making 41. I know I let you guys down by missing 9 of them. Now, once we get through that, we know that in this specific question, we're looking at 7 or more for our x. So that means it has to be 7, 8, 9, and 10, which means I'm going to have to do this formula over multiple times for 7, 8, 9, and 10, and then add all those probabilities together to get me my final answer. So let's go ahead and look at that first equation. So if I plug in for 7, you can see for n I put my 10, for x I put 7, probability of success is 0.82, which is really just the 41 over 50, and 18 is the 9 out of 50. So when we're looking at this formula, I went ahead and plugged it all in, and it gives us 17%, a little bit above 17%. Now, if I do that same thing and plug in the numbers for the 8, that's going to give me 29, almost 30%. For the 9, it's going to give me 30%, a little bit more. And for the 10, it's only going to be 13.7%. So when I add together all of those percents for the 7, the 8, the 9, and the 10, what's the probability that Mr. Caproni would make somewhere 7 or more out of those 10 attempts? It's going to actually be a 91.1659% chance that I would make 7 or more. Obviously, because I'm a bala, and you can see that my shots were on fire. So thanks for joining me today. I hope you got something useful out of this video. Remember, my name's MrCaproni, and if you like this video, click the like button below to help me out. And if you want to see more videos like this, go ahead and subscribe to see my new weekly videos every week. And hopefully you can jump into my ACT prep program as well. Again, thanks for joining me, and have a fantastic day.